Okay, I'm just trying to get this to work. I need to, okay. Let me try this. This is the first time without a class. So this might be harder to do. Okay. Okay, we spent the last unit working on the unit circle, and on that unit circle, we are going to now use the coordinates to draw out our sine and our cos graph. Okay, so we've done some of this in the applied course. So it works like this. If I'm looking to graph y equals sine theta, I start at 0, and at 0 my value for sine theta is also 0. Then I go to 1, back to 0, -1, and 0. And all I'm doing is following my sine coordinates all the way around the unit circle. We know that it's a periodic function, so that it continues on forever. And I have an amplitude. That's the distance from the midline or the equilibrium is 1 for this. My period is 360 degrees or 2 pi radians. So it repeats itself over 360 or 2 pi radians. I have y-intercept that occurs here at 0. X-intercepts occur at all my pi values. So we'll talk about that a little bit more as we go along. So my x-intercepts, or my roots, or my zeros of my function, occur at k pi, where k is an integer. All right, we talked about that notation in the last unit. So every pi value, I have a 0 as my x-intercept, or my root. Okay, the domain for this, the domain for it is x is an element of all reals, goes left and right forever, and the range is -1 is less than or equal to y, is less than or equal to 1, where y is an element of all reals. Okay, and that gives us our amplitude as well. Our midline is y equals 0 in this case. Now, if I'm looking at the cos graph, the cos graph starts at 1 and works its way around the circle the same way the sine graph did. I put arrows on the end, and all of my values stay the same. So my intercepts are the same. My y-intercept is different. My y-intercept in this case is 1, not 0 like the sine one. My amplitude stays the same. My amplitude is 1. My x-intercepts for cos, they occur at this value here, which is pi over 2, and this value here, which is 3 pi over 2. Okay, so now this is brand new notation for us. We haven't seen this notation. I'm going to write it as 2k plus 1 pi over 2. where k is an integer, 2k plus 1 means that I'm always going to have an odd number. So it doesn't matter if I put 1 in there, 2 in there, 3 in there, 4 in there, it doesn't matter, because when I multiply by 2, it makes it even, and then I add 1, therefore it's an odd number. And if you can see, this works at pi over 2, 3 pi over 2, the next one will be 5 pi over 2, the next one in the negative would be negative pi over 2. So that's why k is also an integer for this graph. All right. Amplitude, I take my maximum value, subtract my minimum value, and divide by 2. So 1 subtract negative 1 is 2. 2 divided by 2 is 1. The period is found by taking, so my period for this graph is 360 degrees over b, or 2 pi over b in terms of radians. Okay. So it says graph each function for the domain, and then you have to find out from 0 to 3 pi. So that means that we're going past this point right here. This is 2 pi. So this guy's going to come down here. That'll be 5 pi over 2. Right there would be 3 pi. So it would go like this. It would continue on. And then the sine graph would go like this to get back to 3 pi as well. The other thing that we do is on the unit circle, even though I used only my 90s to begin with, these values also occur here. So at this point, at 30 degrees, or pi over 6 radians, I have root 3 over 2 and 1/2, let's say. Well, looking at my graph, okay, root 3 over 2 is right here. The sine value is 1/2, which is down here. Okay, at 45 degrees, they're the same value. That is right there. They're both equal to root 2 over 2 and root 2 over 2 at that coordinate right there. The same thing occurs down here. Down there, they are negative root 2 over 2 and negative root 2 over 2, which is at 5 pi over 4. Okay. One of the other things I want to look at that we have done this year so far, and that is our standard equation for a sine graph. Y equals a sine b x minus c add d. Okay? A is my amplitude, which means it's a vertical stretch of all the y values. I multiply all the y values by that. B affects my period. Means that I take all my x values and I divide them by the b value. C moves the phase shift left or right. D, of course, is the vertical shift up or down. So just to pick a couple examples, the first one, they have y equals sine 3 theta. So for y equals sine 3 theta, all that's doing is changing my period. So if I were to draw it out, I draw it the same each time, put my 5 key points down. Now the difference being, this point, instead of being 2 pi, is now 2 pi over 3. Okay, that's the period. I've shrunk the period. I've divided all my values, so this would be 1 pi over 3. This here would be pi over 6, and this one would be 2 pi, 3 pi, what is that? 1 pi over 6, 2 pi over 6, 3 pi over 6, so this would be pi over 2, right there. Okay, so when we're graphing these, my period changes by a factor of 1/3. And if I look at the next example, they give you y equals -4 cos theta. So there's two transformations here. The first transformation is the negative value. So that means it starts down here now and works its way up. And then the change is also, this is -4 and this is +4. So it's a reflection over the x-axis, and my amplitude changes from 4 to -4. Okay. Okay. Which notation? Go back a page. Oh, I'm guessing you're talking the one down. Sorry. No, where's that next? There. That notation there. I'm gonna write it down. So the important part is the 2k plus 1. Okay, good. So 2k plus 1 times pi over 2 means that it's every odd value of pi over 2, I end up with an intercept or a 0. Okay? All right. So that pretty much covers what you need to have done today. So go through 4.1 sometime today, and if you have any questions, then ask those tomorrow. All right. You have everything written down now? All right, perfect. All right, that's all we have for today. Video was okay? Somebody said yesterday it was blurry. Is it blurry? Okay. I'm going to have to see how to adjust the camera then. All right. I'll okay. I will have to play with the camera and see how to fix that. I'm not sure. All right. Okay, that's all I have. I'm going to close it down. You're the only one on, so I'm going to leave the physics till tomorrow. Okay?